Hey, welcome to Gold Scratch. So a few days ago, I made a video, Fasteners 101, and I introduced a whole bunch of topics about fasteners. And based on the responses and the questions that I got on my channel, this is Fasteners 201. And we're going to fill in a few things that I didn't get around to doing. And the first one, I had to kind of cut it short. A couple things. I promised a screenshot of this sketch, this drawing. It will be on the video this time. I'll also have a screenshot of a torque chart that I used in my corporate days, if it's helpful for you, for a wide range of fastener sizes. And also a page out of my manual, which is the torque chart for every Chevrolet engine built in 1968, right from a six-cylinder up to an L88. So that might be helpful if it's helpful to you. And I also said I would put a screenshot of Trevor and I in Victory Lane. There's a little trophy again. If you watched the first video, I talked about that a little bit, so I won't go over that. So just to summarize, based on the questions that I got, I want to make a couple points. Usually we consider, when we want to tighten some torque, a torque is just a convenient way that's pretty accurate, and accurate enough for most applications to get the correct stress in a bolt, and a bolt, which fastener system, which is a bolt, not in a washer, two washers hopefully, depending on the application. And the whole idea is to create a clamping force. So you do that by stretching the bolt, making it longer than it wants to be. Okay, use this main bearing bolt, making it longer than it wants to be, and when you stop torquing it, it wants to go back to its original length. And for a way more detailed explanation of kind of the science of it, I really hope you'd look at Fasteners 101, because it covered this in a lot more detail. But torque is just one way to get that, and for most applications, it's accurate enough. So the torque in this, which we already covered, this is a bolt and a connecting rod of a CT400 or a ZZ6 crate engine. 45 foot-pounds is 6/1000 of an inch. And there's a number of ways you can get that. You can torque it with a torque wrench, okay? Simple torque wrench to 45 foot-pounds. And as long as the threads are clean, there's no burrs, there's no hang-ups, all that stuff, then you'll have 6/1000. I've actually done this. I built a few of these engines. And when I did that, I actually went 45 foot-pounds and measured the stretch, and guess what? It was exactly 6/1000. Plus or minus less than 1/2,000. So that's good enough. Now, there are other ways to impart torque and to create a clamping force. What you're trying to do is create a clamping force that holds any two parts together, whether it's a connecting rod cap onto the connecting rod, main bearing cap onto the main bearing, etc., under the block or whatever. You need a lot of force to hold it together. And I'm going to give a simple calculation of that before I'm done. But there's other ways to do that. And one is in the new LS engines, and I'm not an expert on LS, but I have done some work on some of them. Typically what they use is a torque to turn method, and that's a gauge that is useful for that. So in a typical bolt application for an LS engine, I might say torque to 20 foot-pounds and then turn 90 degrees. So the 20 foot-pounds is just enough torque to take up all the slack in the system, but not enough to stretch the bolt. So you just put your socket there, your ratchet there, and you turn it till the dial goes to 90 degrees or whatever number of degrees is specified, by the manual. And that is actually a more accurate way, because what they've done is calculated the pitch of the thread and decided that 90 degrees is a quarter of the pitch. So whatever one thread is will give you the stretch that's desired. So that's actually a more accurate way. And in big industry where you'd need a torque wrench 25 feet long to get enough torque, that's the method that's typically used, is torque to turn. So while we're talking about LS engines, somebody suggested that I mention it. A lot of the LS engines in a typical application for a Generation 1 engine that we have. By the way, we have a video coming up, and I just remembered, please remember to like and subscribe. while I still got you here. Subscriptions are really important to me, and we're growing our channel and we need more. And likes are good because then YouTube might show it to somebody else that'll subscribe. So anyway, back to what I'm talking about. So the torque that is required to get to the yield point, as I mentioned in the first video, once again, I'd like you to watch that. Once you get to this point, this is called the tensile strength of a bolt. And once you get to that point, the bolt stops to be this is the elastic range, elastic zone. What it means is when it's stretched to this point, as long as you release it before you get to this bend, it'll go back to the original length. If you stretch it farther than that, it goes back to this length. This is just the curve of failure. And I think I called this the elastic curve, but it's actually called plastic deformation, where the bolt necks down before it breaks. I didn't get that right in the first video, so I'm just correcting that. That's the ultimate strength of the bolt. But in a lot of bolts used in the new LS engines, they use what's called torque to yield. So they're actually torquing them up to this point. And for that reason, you're not supposed to reuse them. Now, people have reused them, and they claim they've been okay. I wouldn't try it myself. But typically, if you take a head off an LS, you've got to buy a bunch of new head bolts. So, because they're torque to yield, which means you're up into this danger zone where you could get permanent elongation, and the bolt should be changed. So, the third way of measuring is for very precise measurements, and it is absolutely the most precise, is measuring the elongation of the bolt. And there are special micrometers designed just for connecting rods to do that, with little pointers on them, and they go to either side of the bolt nut, or the bolt, and either side of the bolt, and they measure exactly how much you're elongating it when you torque it. And typically you also have special bolts with a little dimple in them to line up with those little micrometers. Absolutely the most accurate way to do it. However, for ordinary applications, for engines that we're talking about, torquing is just fine as long as you have a good torque wrench, it's calibrated, and you make sure the bolts are nice and clean, the threads are clean. We're going to show you in a minute when we do the video on Mike's engine how we do that, and lubricate it properly with whatever lubrication is supposed to be done. You will be in this zone here. So this is 75% of the yield point, and so if it's 78 or 72, it's not going to fail. It's going to be fine. That's why it's 75. That's basically a safety factor, and so that's good enough. If you're conscientious in the way you do it, once again, your threads are good, you have a good torque wrench, you do it meticulously, you'll be just fine. A couple other things. We talk about tensile strength of bolts. So let's assume this is a grade 5 bolt. So a grade 5 bolt has 120,000 psi tensile strength, which means this point there's 125,000 psi of stress in the bolt. So at this point you'd have 90,000 psi of stress in the bolt. So and just to show you some examples of bolts, most people are familiar with this. So this is a grade 5 bolt. I don't have a grade 2 bolt in my shop to show you. We call those sort of garden variety bolts, and probably you should stick to grade 5 or better on an automotive application, especially if it's on an engine. So look for the 3 radial lines, and that's 120,000 psi. That's a grade 8 bolt. They're also usually shinier, and they look nicer because they're going to charge you a lot more money for them, but they're 150,000 psi. And this bolt is a metric bolt according to the DIN standard, and I'm not sure what the spec is on this one, but it's a DIN standard. Once again, you could look that up. Speaking of standards, there's 3 that are important. SAE is the Society of Automotive Engineers, so a lot of bolt torque charts are based on SAE. ASTM is American Society for Testing Materials. That's another set of standards. And then there's a DIN standard, which is a European standard basically, but any metric bolt will be assembled on the DIN standard. So I hope that fills in a few gaps based on the questions that we got. And if there's any more questions, we'll do fasteners 301 if we have to. So once again, before I forget, I hope I've covered that. Please like and subscribe. And as soon as this video is done, we're going to talk about Mike's budget build. He just got the block back here today, and so I can finally get going on it. He's had it at home cleaning it for a few days and getting it ready, and we're ready to take it to the next step. Thanks for watching Gold's Garage.